Good evening. Welcome to the first of a series of webinars that West Island School is putting on, which will allow you to see what happens throughout the school in each faculty. My name's Mike Williams. I'm Vice Principal with responsibility for curriculum and assessment, and I also oversee technology throughout the school. So I'm going to introduce you to our first host, who is James Playford. He is the head of the Design Technology department. So James will be talking to you for about 30 minutes about the Design and Technology curriculum. If you do have any questions, then you can see at the bottom, on the taskbar on the bottom, you have the Q&A function. If you can put the questions into the Q&A function, I'll try to answer them while James is going through the presentation. And if there's anything I can't answer, which James needs to, we will tackle those questions at the end. So without further ado, James, if you'd like to start, thank you.
Good evening, ladies and gentlemen, and welcome to the presentation about the design curriculum at West Island School. It's my great pleasure to be speaking to you this evening, and I see we've got a rather large turnout, so that's very pleasing indeed. I love design and I love speaking about design, so I'll try to keep this to just 30 minutes to give you an overview of why design is an important subject and what that looks like for your child at West Island School. So I'm just going to share my screen. And I'm going to make sure I share it with the audio switched on. Yep, here we go. So I'm hoping that you can all see that, and we'll be able to hear some of the video that we'll be playing for you later. So the first question I have is, what is design? What is this thing that we call design? Now, I think for many people, if I ask that question, that they would think of this. So the sort of garments that you might see on a catwalk in a fashion show, or a concept car that you might see in a magazine or at a fashion show or at an automotive show. To me, these are one single aspect of design. These are just about styling. And although styling is important and an important aspect of design, design is so much broader and so much more important than mere styling. For me, this is what design's about. It's about the creation of everyday objects that fulfill a function, often a simple function, but make life better for people in a particular way. So a simple device like the paperclip, a device for holding paper together, or as my first head of department used to say to me, James, a paperclip is a device for holding the mind together. And I always thought that summarized it rather nicely. So all the objects that you're looking at on screen have been designed. They've all been made. A designer or team of designers has worried through every one of the detail. They've had sleepless nights about exactly the color of blue that the asthma inhaler will be made from, or exactly the right type of material that's going to be used to give us the properties that are required for it to fulfill its function and to make our life better in some way. Here's one of my favorite stories about design. Because design is about problem solving. And as I've said a couple of times already, it's about making things better for people. The blue bottle on your screen is a bottle that's used for non-carbonated drinks. The green bottle is used for carbonated drinks and is the newcomer of the two designs. With the original design, you can see that the screw thread is quite an aggressive screw thread. It comes up quite quickly. So with a single turn of the hand, you're able to remove the lid. Now that's fine for a non-carbonated drink, but if you were to take the bottle full of carbonated drink, you were to shake it vigorously and loosen the lid, you could actually find that the lid would explode off with a violent force and cause injury. And in fact, it was injury caused to someone in the United States that led, and the subsequent lawsuit, that led the manufacturer to go to a team of designers and say, solve that problem. We need a bottle that can be shaken, and when the user removes the lid, it's not possible for the violent explosive force to cause the lid to fly off with a degree of destructive force. And the way they did that was twofold. Firstly, they altered the thread so it was a much lazier thread at a much shallower angle. So it meant the user would turn the bottle cap once, but wasn't able to fully release it. So they had to take their hand off and reapply it. And that small amount of time that it took for them to take their hand off and reattach it meant that the gas was able to escape down through the channels that are indicated there by the arrow. So a problem, how do you stop the user misusing this bottle and causing injury to themselves and others? Solved through a process of design. I'm now going to show you a video. This video is produced by the Design and Technology Association. They're based in the United Kingdom, so the video is rather UK-centric in terms of the numbers used and some of the industries referred to, but it does explain very well what design as a subject is about.
The word design means different things to different people. Often it's associated with how things look. Often it's used as a noun, as in that's a good design. But really, it's a verb. It's not an it, it's a how. It's a way of doing things. It's a way of thinking. And above all, it's a way of thinking creatively.
Design to me is really taking ideas and turning them into a practical reality. The process of taking that idea and turning it into metal or plastic or a physical object is design.
Everything around us has been designed, from our latest digital app to the car we drive, the clothes we wear, the buildings we live and work in, much of the food and drink we consume, the TV programs we watch, even the deodorant we spray. They've all been designed. They've all been made.
It's design and technology that makes the world work, that turns ideas into reality, and that's super critical to successful innovation, and therefore the future prosperity and economic health of the UK.
Indeed, last year the UK's engineering, manufacturing and creative industries sectors were together worth £500 billion, with the creative industries sector growing last year by 10%, 3 times more than the wider UK economy. The spark that ignited so much excellence in our creative industries was the revolutionary inclusion of design and technology in the first national curriculum in 1989.
Design and technology is a phenomenally important subject. Logical, creative and practical. It's the only opportunity students have to apply what they've learned in maths and physics, directly preparing them for a career in engineering.
Since the introduction of design and technology in the 1990s, there's been a clear correlation between the numbers of people taking D&T and the increases in further and higher education going on to engineering and other subjects related to D&T. The link between D&T and engineering and the creative industries is clear and obvious.
So, what does design look like at West Island School? No, that's not actually what it looks like at West Island School. That's perhaps what sometimes people think of when they think of design in schools, a very traditional setting like that. But I would now like to ask some of our students to tell you about their experiences.
Project seeks to combat is food waste. I've noticed that a lot of developed countries don't have adequate systems in place to deal with unwanted food. And in the US, 15% of this unwanted food that gets thrown away is from restaurants. So I've decided to redesign the doggy bag in hopes to encourage more people to take their leftovers home. I've decided to use banana leaves as my material because I wanted to incorporate the environmentally friendly approach to my design.
So the reason I made this product was when I was injured in school and I was on crutches, I found it difficult to find a place in class to put them. So I thought I would use a piece of existing stationery, which is a bulldog clip, and design something that you could attach to it to hold the crutch to make it easier for myself and to not have it disrupt other students in class.
I realized that there's no way for reptiles to be transported from pet stores to homes in a way that doesn't create waste and makes them feel comfortable, because right now they're using plastic containers. So I took the bedding that you put in their tank and I'm turning it into paper, and then the paper is going to be made into a carrier that you can take them home with, and then once you're home you can rip it up and you can use it in their tank.
Lamp. So first I've laser cut this shape into the plywood so that it would bend more. And then I've attached LED strip lights and wired it up and then used copper tracks.
Basically my model is basically a gadget tidy, and it holds phones, wallet, keys and watches. So as you can see in this part, you have a space for wallet, and this part it holds the phone.
So it's a lamp which activates when you place a bottle, water or wine on top of it, and it presses down and it'll refract the light from the water.
I'm designing a wine rack which can fit 6 wine bottles. When I was making these, laser cutting these holes into the plywood, then one of them I made, the holes were too big, so it was too flexible. And then the second one I made, it wasn't flexible enough.
We have to stick the wood together and without it being bent or being, making it collapse. So it's really difficult getting the materials sorted, because you have to find the right materials if it withstand the weight.
Being more independent, because you don't always have the attention of one person, and when you are struggling, you have to work it out for yourself sometimes.
I think just the skill to think more logically and assess the problem solving. So when you encounter an issue with your product and its design, you just think for a way around it to make it work.
Make sure you're inspired by what you're making. Don't make something because you think it's easy or because everyone's doing it. Make something because you want to do it.
Just make use of every lesson. Don't wait to put the things in the last minute.
Just keep on thinking at it, and then you can improve it until it's a product that you'll enjoy.
You always have to think outside the box. Don't stay in your comfort zone. Do something new and, to experiment with new things.
First one that we did was creating our own logos for ourselves. Second one we did was creating our own Google Classroom banners for the classes Google Classroom. And we've also taken part in creating an infographic for an NGO based in Hong Kong called Plastic 3Cs.
We've learned how to use, develop skills in things like Adobe Illustrator, Photoshop, and things like Google SketchUp and other programs. And we've also used things to do with printmaking, making packaging nets, and laser cutting.
We've done many projects. For example, we made a hangman program, we made a battleships program. At the moment, we're making a user interface, which you can actually use on your computer, which is really cool.
It's different from other subjects that you can learn outside. So you get to code games which you can't learn outside.
We've done 2 projects so far. One was where we designed something for ourselves, and another one we're doing right now is a toy that we designed for a younger audience, like a pull-along toy.
I've learned how to use a wide range of equipment. The teachers showed us how to use that they use for us.
I definitely recommend resistant materials because For me, I think it's a great way to express what you want to have and manufacture it into this product you have, that it's really unique and it's something that's completely yours, and throughout the process you get to learn and refine and do all of this just to make this outcome that you can be really proud of at the end.
In Year 9 we've done a variety of different foods, from curry to Christmas cookies. We've learned basic skills for cooking, but we've also learned how to make our meals healthy and the nutrition about it.
I like that you get to learn about nutrition, so you get to learn about healthy eating, and you also get to learn about cooking. There's a lot of practicals involved.
We've done bags, we've done trashin for, like right now we're doing trashin. I've learned a lot. Sewing, using the machines, painting on the fabrics. You have full creativity over your work. It's like yours. You can put your creativity into it, and it's not like we only allow you to make this and only this, and you cannot use any other materials. I just like the teamwork sometimes, and I like the bags. You can expand your creativity. If you like textiles, you could do more.
Graphics doesn't seem like much, but actually it has lots of skills which are transferable to other subjects, whether it be creativity or working as a team.
It's definitely one of the leading subjects which are basically leading innovation. The leading technological and scientific advancements in humanities.
Knowing how to cook is a really good skill to have in life, and also knowing your nutrition is also really important.
Enjoyable, immersive, and graphical.
Unique, fun, and interesting.
Really amazing subject.
So I hope some of the themes that were coming up there sounded familiar to you. When we look at what has been some of the sort of big talking points in the last 3 to 5 years in Hong Kong and in wider society, we're hearing terms like design thinking, and we're seeing the emergence of maker spaces. And I think that's really, people are starting to understand at a wider level in the corporate world the value of learning through making, and the value of following the design process, the design cycle in problem solving. So what does it look like at MYP? At MYP, there are 4 stages to the design cycle. Traditionally, one would think about it in terms of, first of all, you investigate, then you develop some solutions, you manufacture, and then at the end, you evaluate your success. But I would argue, in fact, this cycle can be used way beyond what students do in MYP. It's useful in all aspects of curriculum and also life, and can be attacked from a whole number of different angles. It's possible to start with the evaluate. So if you are using an existing product, you might start by evaluating how successful that is, then investigating how it could be improved, coming up with concepts for improvement, and then making them. And equally, you can start on any one of those stages of the design cycle. I think if we look at what are the increasingly important skills for our students as they go out into the wider world, these are just a few of the skills that I think are really, really important that they develop. And design as a subject allows the students to develop those subjects through action-based activities. So it's not about learning the theory behind these things, it's actually being involved in all these areas on an ongoing basis and seeing how increasing your skill level in these areas is going to help you to improve and help you to get to a better outcome. MYP has 144 approaches to learning. So they're areas that we as a school believe in and we want the students to develop as they progress over time. For Year 7, we focus on this. I think it's incredibly important for students to learn that failure is an essential part of any learning process. And I'm certainly not alone in this. So I'd like to just share 3 quotes with you. I've stolen this one and modified it slightly as become obvious, but I think if we put the word problem solvers instead of artists in there, I think that's incredibly powerful. If you look at a toddler trying to learn to walk, they'll stand up, try to walk, fall down, get back up and go again. When they're trying to learn language for the first time, they won't be discouraged by getting a word or a sound wrong. They'll just keep going and going and going and learning from each of the failures, learning from each of the time it's gone wrong. And to help students retain that skill, to retain that ability to celebrate and learn through failure is incredibly important. When students get to be teenagers, they often become almost terrified of getting an answer wrong or making a mistake. And I think that's such a shame that that really can hinder learning. So design has a fairly unique place in the curriculum to allow students to understand that failure and mistake is simply a part of a process and an essential part of the process. And we'll explore that in another quote. This gentleman is Jonathan Ive, who was until very recently the head of industrial design at Apple. So if you've ever owned an Apple product, it was Jonathan Ive that will have been in charge of the design process of that. And what he says here, I think is just so powerful, that if we're not willing to fail, we're never going to learn how to be successful. We have to be open to that process of making mistakes, making errors, making failures, but then having the skill set to learn from those failures and to move forward. Finally, Henry Ford, behind the Ford Motor Company and also the inventor of the moving production line, said this: failure is simply the opportunity to begin again, this time with more intelligence. And to me, that's just such a powerful statement. I have that up on my classroom wall because I think, again, it just illustrates to us why it's so important that we study design, that we study engineering, we study computer science and creativity in the way that we do. I'd now like to talk to you about the progression through West Island School. So all students have design classes in year 7, 8 and 9. In year 7, we focus on product design. So that's building things using woods, metals, plastic, textiles and food. In year 8, we progress on to digital design. So that is more design in the virtual world. So that's computer science, that's graphics, that's 3D modeling. In year 9, the students then choose 2 subjects that they will pursue for the whole year. And these are the subject choices that point them towards their post-14 options. So the list of subjects: computer science, creative media, which is graphic design, food preparation, nutrition, product design, and textiles. When the students then begin their post-14 courses, or their pre-16, as we also know that, they get the choice of taking a range of BTEC or GCSE and IGCSE subjects within the faculty. So we have, again, computer science, creative media, engineering, food preparation, nutrition, product design, and textiles. When the students then get to their post-16 study, we have a range of courses available to them. We have the BTEC program, we have the IB-CP and the IB-DP programs. And within the faculty, we offer the following subjects. We have BTEC engineering, we have IB-DP computer science, and IB-DP design technology. Many of our students go on to study related subjects at university. Just yesterday, I asked for a list from our careers team, and it was so many that I wasn't able to fit it onto a slide in a meaningful way. So from just last year, these are the ones that illustrate the range of courses and the range of institutions that our students from last year are now off studying. So I'll just give you a second to look through that. And finally, from me, I would just like to give you a couple of my favorite sources where you can learn more. I've included one TV show, which is, it's a little old now, so it's available readily on YouTube, called The Genius of Design, which across 6 episodes explores aspects of what design means and why it's important to the world. and my very favorite podcast, 99% Invisible, that explores design and the manufactured world, and each week takes us through a different story that relates to how things are designed, how things are manufactured within our world. So that's it for me in terms of the presentation. I'm going to invite Mr. Williams back to us now so we can look at any questions.
Thank you, James. That was absolutely fantastic and extremely informative. As you can see on James's picture behind him, he has got, I don't think he's still in school. It can't be daylight in Popful Land. So I believe that is a background, but you can see just a little bit of the equipment. But if you actually go into the faculty, which I was there today, the amount of equipment is absolutely amazing. It's kind of industry standard resourced. It's the most resourced school in terms of technology that I have ever worked in and actually ever been to. And I don't know anyone who would say any different. Do you just want to go through a couple of pieces of equipment we've got there, James?
Yeah, I mean, it's interesting, just following up from what Mike was saying, we often have students that have graduated from us and are at university who will get in touch and ask to come back into school to use our equipment because we're better resourced than many universities, which is it's a lovely boast that. So we've got a fantastic mix of traditional and modern manufacturing equipment. So we have a range of 3D printers, which I'm sure is some technology you've heard about. We have a range of laser cutting equipment. We have a range of sublimation printing equipment. We also have invested heavily recently in some other computer-aided manufacturing equipment. Just this week, we had delivery of a new computer-controlled router. So what I'd like you to imagine from that is a spinning cutting tool that will come down and automatically cut out any design that you can generate in the computer in sheet form that can then be assembled from woods, metals, and plastics. We also have a range of traditional equipment, like I say, so we have a full suite of welding equipment, casting equipment, and if you're familiar with some metalworking equipment, we have lathes, milling machines, and that's just the product design area. We have 2 complete food laboratories with, again, a very wide range of equipment there. We have a textiles facility that again has sublimation printing, laser cutting, computer-controlled embroidery. We even have an edible printer. I don't know if you knew that, Mr. Williams, but we can print our own images on other food products.
Thanks, James. Yeah, I was in there today, as I said, and one of the extended engineering students had I think made a wooden model, and I asked them what they were doing with it, and they were scanning it, and then at the same time, it was, once they've scanned it, it printed out a 3D plastic version of that, and I was just standing there absolutely amazed at where we've come in technology. And I've seen people in technology using virtual reality, augmented reality, AI, and we're really on the cutting edge. We've also got a future-proofing program with a lot in year 10 and 11 there, which we use an awful lot of technology in, and we're really just trying to push this, how far can we go in school with technology. And the students that do stay with us throughout the course, they absolutely thrive in it. And I mentioned the engineers. We have got students who spend virtually all their time in the faculty working on their extended engineering BTEC diploma. You see them welding and laser printing, and they just absolutely thrive on what they're offered within our school. Okay, so yeah, we would love you all to come into school, but at the moment, obviously, with the restrictions, we can't. As soon as we can, we're going to invite you in and have a look and have a talk face to face, because we prefer to do this face to face as possible, but we can't. So James has done a really good job of showing you around the faculty. Please get in touch if you want to ask any questions whatsoever. I've got no outstanding questions that we need to ask James. So without further ado, thank you very much to James, and thank you very much for your attention. And we look forward to seeing you soon. Okay, bye-bye.
Bye-bye.